Okay, so we're going to continue section 2.2, question 10 onward. Unfortunately, question 10 relates to number 9 as well. So I wish I'd known that or read that. And we're going to try it out, okay? You won't be asked the normal too often, and I'll explain what the normal is. Suppose you have a parabola, okay, and you picked a point right here, right there, let's say, and you found the tangent line, the slope. All right, and you found the m, the slope of that tangent line. The normal is a line that crosses through that same point, but is at 90 degrees to your original tangent line. So it's 90 degrees. And this line is called the normal. Now, we're not going to use it much, but it's important to understand it for now. And the key point that you'll have to understand is it's 90 degrees to this m, and it will pass through the same points as the tangent point you were using. Okay? How do you figure out the normal? Well, when you have the m of this line here, the slope of the normal will be -1 over m. And I'll give you an example. Suppose this slope of this blue line was 5. That means the slope of this normal line will be -1 over 5. So essentially the reciprocal of your tangent slope and opposite sign. Suppose your slope was -2. That means this one will be -1 over -2, which means, since we got to apply the minus to it, we're talking about +1 over 2. Makes sense? That's the reciprocal and opposite sign of -2. Suppose your tangent line was -1 over 3. So you just put that in here. Right away you can see your negatives are going to become positive. And what's 1 over 1 divided by 1 over 3? It's the same as 1 over 1 times 3 over 1, which is 3. So that makes sense. We had a -1/3. What's the reciprocal? +1/3. So one way to see it is just flip your numbers upside down and change the sign. Okay? Flip whatever symbols you found for n upside down and change the sign. And that'll give you the slope of this line. And then you got to use this point and that slope to figure out the equation of that line. And what you do is you put in your x values there and your y values there, and the slope that you found there, if this is the new slope, you put that in there. And that's how you find the equation of the line. And that's what they're asking for 10. And they're using specifically 9b, which I didn't keep, unfortunately. But very quickly, I'm going to solve the tangent for it. And this is why they gave you 2 points in 9b. We're going to solve the tangent for it. You get 3x to the -2 minus 4x to the -3. You get -6 over x cubed and +12 over x to the 4. And then when I put in -1 here, stays -1, this becomes +1. So I get +6 plus 12, which is 18. So that is the slope of this tangent point. And they're asking me to find what is the normal. The normal, as I said, we're going to use the same point, and we're going to use the slope we discovered, m of 18, except the slope of the normal, this was the slope of this thing like this way, and actually it's going up. 18 means it's going up. It means the normal is going to be at right angles, and it doesn't matter visually if you draw this. It means the slope is not going to be 18. What did I say I do with the number? I flip it upside down, 1 over 18, and change the sign. So that means the slope of my normal is going to be -1 over 18 instead of +18. So I don't need this anymore. And it's going to go through that point. So we're going to write the equation of a line. y is equal to mx plus b. And keep note that equations for the tangent line will always be a line. Equations for the slope will not be. But anyway, all we do is we put minus 1 in for x, and we put plus 7 in for y, and we put negative 1 over 8, m is equal to negative 1 over 18, rather, in for the slope. So we rewrite it as 7 is equal to negative 1 over 18 times minus 1. You can see what's going to happen there. Plus b. We're trying to solve for b. So that becomes positive 1 over 18. So b becomes equal to 7 minus 1 over 18. Or, if we put it into this format, well, let's just keep it simple for now. It becomes 6 and 17/18. Now, it might be possible that your teacher wants that in fraction format. But now we have the slope, and we have the b, and we can rewrite our entire normal equation with formula for the line that forms the normal is y is equal to 1, negative 1 over 18 x plus 6 17/18. How would I convert that into a full fraction? You multiply 6 times 18 and you add the 17. So 6 times 18 is 48, 108, and you add 17 and you get 125. So if I'm going to convert this whole number into just a fraction, I get 125 over 18. Learn how to convert your fractions. It should be child's play at this point. So that is the formula of the line of the normal to this particular situation, to that particular point. The lines are very specific to the points. Great. That's that one. You won't be using the normal too much, but at least you should know what the normal is. The normal is a line that is perpendicular to the tangent line that runs through the same point. Okay, so 17. We'll do that and then just crop it. Determine the values of x so that the tangent of the function to this function is parallel to the line. Okay, so first let's answer what is the slope of this line. Okay, it's 16y is equal to negative x minus 3. What did I do? I moved it all to this side. Then I divided, or better yet, I multiplied by the reciprocal on all sides. So on this side, I get negative 1 over 16, there's the slope, and this times 1 over 16, and you can't really simplify it, so it just becomes negative 3 over 16. They're both divided by 3. No, they're not. Okay, so now I have the line equation. Y is equal to, and more importantly, I have the slope. Okay, so that's step 1. I figured out the slope of this line, which is going to be the same slope as my tangent line because it is parallel. All parallel lines have the same m. They have to. Otherwise, they would eventually cross and not be parallel. Great. Now all I have to do is figure out what is the derivative of this using our power rule. Okay. This is the same as 3 over x to a third, which is the same as 3 times x to a minus third. That's how you get an exponent up to the top. You just change the symbol. Okay, so now that I know that, I can convert it using the power rule. I bring the negative a third out front, multiplied by 3, they cancel out. I'm left with a negative x, and I lower this by 1, minus 4 thirds. Great. What does that mean as an equation? It means this. It's equal to 1 over x to the 4 thirds, positive now, because I brought it down to the denominator. And that is the same way as saying x to the 4, but cube rooted. Great. So now we know a formula for the tangent, but we don't know the x and the y values that are parallel to this line. But we do know an m, and we do know that that m is also going to be equal to this formula, because this formula also produces the m of any slope. Great. Now all we have to do is solve for x. And I'm just going to put this all smaller over here in case I forget something. And I'm going to put that over here in case I forget something. Great. Now all I have to do is solve for this. Well, as I said, whenever x is at the denominator, we can't solve it. So how do I bring this all up to the top? You multiply, you treat this as one big number, and you multiply both sides by the reciprocal. So that means this right side is going to be this left side is going to be multiplied by that as well. All right, they cancel out on the left side, and I'm left with this, negative this, over 16. I'll just make it a bit smaller so it fits, is equal to 1. Great. Now I have this whole number, and remember we kind of do reverse bedmass to solve these things, so you don't do the square roots or the exponents first. You are going to get rid of, you can get rid of this negative too, but we'll do that in a second. You got to get rid of this 16 down below. So I'm going to multiply by the reciprocal. So they cancel out here. So I'm left with this is equal to 16. Now I could have also gotten rid of the negative at the same time. Essentially divide by negative 1 on both sides, and it becomes negative 16. Whenever you see a negative here and it's multiplying, you can pretty much move it to the other side and multiply whatever's over there by negative 1. Just be aware that if you have a long thing in here, like 4x and whatever, you have to multiply the whole thing by negative 16, by negative. But right now I have this. Okay, so how do I get rid of a cube root here? How do we get rid of a cube root? We're going to, and actually this, I might have done a small error here because I can see in here. We'll see. Anyway, how do I get rid of a cube root? We have to cube it on both sides. And that's where I think I might have made a mistake. So I'm left with x to the 4 is equal to 16 cubed, negative 16 cubed, which is 4,096. And it's negative, so technically I shouldn't have an answer. But again, I think I've made an arithmetic error. Just out of curiosity, I'm going to take 4,096 and see if it has a cube root. And it does, it's 8. So I believe what I'm looking for here is 8. I can see all my x values are going to be above 0 because I can't have a negative down there. I can't have a 0, so all my x values must be bigger than 0. And this still is. And I could solve it and see if, or see where I made a mistake. So I probably made a mistake somewhere. No, that's correct. The m is indeed minus 1 over 16. And this whole thing has to be equal minus 1 over 16. I guess because you can have a cube root, but you can't have a 4 that's... So let's see if I can solve this. If I have a minus 8 in there, oh yeah, it can be minus 8. So when I forgot that when you take the square root, you have to add plus or minus 8. So let's see if it's possible to have plus or minus 8. And if you took the, no, but if I take the 4 of it and then the cube root, I cannot produce a minus 16. Did I have a minus 1? Was there a minus 1 up here that I forgot? Yeah, there's a minus 1. God damn it. So this is not negative 16, it's positive 16. So when I cube it, I get positive 4,096. And when I cube, yeah, when I put it to the power of 4, I get that. And then I have to see if there's a cube root of it. 96. And there is. There's 16. So x is equal to 16. So what I forgot here was this minus 1 that had to be up here once I brought out the negative fraction. And see, I failed to do it right there. Okay, so we're talking about x is equal to 16, and just be aware that I made one negative mistake in there. So they're asking us to determine the values of x. So I believe it might be, as well, positive or negative 16. Positive or negative 16. And the clue here is they said values. So we're going to see if we can put in, if we can again go back, so I shouldn't have erased the tangent formula, which is negative 1 over cube root of x over 4 is equal to negative 1 over 16. So essentially, we're going to see if both 16 and minus 16 work for this, and I believe that they will. Because when we take the cube root, or when we put that to the power of 4, whether it's negative or positive, whether it's negative or positive, it'll become positive, and then you can take a cube root of it. So either one will work. So x can be 16, or x can be negative 16. And that's the clue in these is when you see values, you go, oh, there's probably two x's. And had they said the point, we'd then have to plug in our 16 into the original equation to find out the 2 points and negative 16. And notice that negative 16 indeed does have a cube root, technically, because, because a negative can have a cube root. A negative can have a cube root. A negative cannot have a 4 root or a 2 root or square root. Yuck. I rambled on there, sorry. Okay, let's continue. Do these functions have the same slope? Do the functions y is equal to 1x and y 3x ever have the same slope? So to figure that out, you have to find the derivative of this, which is the same as that, and the derivative of this is the same as this, which is the same as this. That's where I screwed up last time. And the derivative of this one is very easy, 3x squared. So the question is, do these equations ever equal each other? That's the only way you can have the same slope over here. And then you solve for x. So how do I solve for x here? Well, I want to get x squared up from over there. So you multiply by its reciprocal on both sides. And I'm left with minus 1 is equal to 3x to the 4. And I think you're going to discover that it is impossible to ever have an x value that will come out to minus 4. And one way to see this is to see if these equations, where these equations cross. Because if they also meet, they will have the same slope. No, not necessarily. They'd have to overlap. So the answer, I believe, is no, because it's impossible to have any value of x in here that comes out negative, because it gets to the power of 4. This is easily seen if you were to map it. You'd see that one is a parabola and one is a rational function that looks like that. And it's pretty clear that they can never really have the same tangent slope, because they're going in totally different directions. This slope here is negative, and this one's negative, but it's never going to match. And they'd have to overlap really at some point perfectly. Like they'd have to do that. And I don't think they do. They actually cross. You can always put it in and see. So 3x squared. You can always put it in Desmos. That's the value of Desmos. So you're talking about the graph 3x squared. And the graph 1 over x. Yeah, you can see when they cut right through like that, it's impossible for them to have the same tangent. It's impossible for those points to share the same tangent. All right, let's continue. And we proved it algebraically. You just got to trust your math. Okay. Ugh. Some days, nothing works. Tangents are drawn to the parabola of this at this point and that point. Prove that these lines are perpendicular. So as I said, perpendicular lines will have reciprocal slopes. So you have to find the derivative of that. It's 2x. And you'll have to find the tangent at 2. So the slope there is 4. So if this is going to be opposite, it's going to have come out as minus 1 over 4. So let's see. Let's put minus 1/8 in here. And 2 times minus 1/8 is equal to minus 2 over 8, which is minus 1 over 4. So sure enough, this is the reciprocal and reverse symbol of that. Therefore, since this is the slope of this point and this is the slope of this point, and they have reciprocal and opposite sign slopes, they are indeed perpendicular. That's the definition of perpendicular. One slope is the reciprocal opposite sign of the other. Okay. Some of these are easy, some of them are not, and some of them just require understanding of lines. Determine the point on this parabola where the slope of the tangent is 5. So you just find the derivative. And sometimes I'm just not going to bother, and that's the derivative. And you have to determine the point where it's equal to 5. So it's minus 2x is equal to 2. So x is equal to minus 1. And then when you put it in there, you get minus 1 plus minus 3 plus 4 is 0. So it's minus 1 comma 0 is the point where the slope is 5. Illustrate your answer with a sketch. You're looking at a downward facing parabola. And if I were to take minus out of it, I get x squared minus 3x plus 4. And I believe I can, no, I don't, oh yeah, minus 4. Sorry, minus 4. And I believe that comes out as x x minus 4, x plus 1, all with a minus. And if I was to sketch that on a graph, and I know it's downward facing, it would cut through the points 4, 0, and minus 1, 0, which I now know the vertex is over at 2.5, halfway between 2.5, it's at 1.5, and I could find the vertex. It's somewhere up here. And they're talking about the point. We found out that the point is minus 1. So it's right at this spot here, and we found out that the tangent there is going down like that. Okay. So notice the slope of this tangent is positive 5, even though the line is going down. The slope of the tangent is red as going from left to right. Whenever you're reading a graph, you start on the left side of the x values and you go this way. So this graph is going up, 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 and then down, down, down. Okay, you always read a graph from the smaller x's up to the bigger positive x's, from left infinity to right infinity. Makes sense when you have time on the x-intercept, because time only moves forward, right? Think of it that way. Okay. Determine the coordinates of the point on the graph at which the slope of the tangent is. Same thing. So find the derivative, which is this, and then notice it says coordinates of the points. And the reason we're going to have 2 points is because of this square here. So this is going to be equal to 12 when we isolate x. This is the derivative formula, by the way. When we isolate, we get this. And then when we square root both sides, this is the big secret that I often forget to do, I have to put a plus or minus 2. So that means when x is 2 and when x is minus 2, it crosses. So when I put x is 2 in here, I get 0.2 comma 10. And when I put x is minus 2 here, I get minus 2 comma minus 6, which makes sense because all parabolas on the matching side let's see, is that accurate? Yeah, that's not necessarily accurate. Let's see. Up. Will that be a slope anywhere? It's 12. I think, oh, I see what's going on. There's a slope here that will match. Oh, it's a cubic. Sorry. That makes more sense. Parabolas will not have two matching slope tangents ever. But a cubic will always have a spot here that matches the spot here. Or the spot here that matches the spot here. It will always have matching tangents. And something to the 5 can have, I think, 3 possible matching tangents. Show that there are 2 tangents to the curve. It's the same thing. So find the derivative of this. You get x to the 4 minus 10. Make it equal to 6. And clearly, when I take a 4 root, I'm going to have 2 possible answers. So x to the 4 is equal to 16. 4 root both sides. So I get x is equal to plus 2 or minus 2. And when I put that plus 2 in there, 2 times 2, 4, 8, 16, 32. 32 over 5 minus 20. 32 over 5. 32 over 5 minus 20. I'll get to that in a second. And I get minus 32 over 5 minus 20. So the 2 y values are these. The 2 x values are these. So 32 over 5 is the same as 6 and 2/5. When I minus 20, boom, I end up with minus, I think it's minus 13 and 3/5. 14, yeah, I think that's it. And when I subtract these two, it's negative 6 2/5, so I end up with negative 26 and 2/5. So this is my y value that goes with my positive 2, and this is my y value that goes with my negative 2x. Same thing, really. They're just giving you situations where you can make more mistakes. So 17, 18, 19. 17, are they going to do it to me again? There's only so many times I'm going to do the same question. Determine the equations of the tangents. So when they ask for the equations of the tangents, equations of all tangents, lines are line formulas. To the curve this, that pass through the following point. Very easy to do, okay? So first find the derivative, it's 4x. And then once you find the derivative formula, you can put x in here, and you can discover the slope for this one is 8, and you have 2 points. Plug them into here to discover your b, and then rewrite your formula with just m, which is 8x, and whatever the b you found. I'm not going to do it because you've done point lines again and again. And for this one, the same thing. So this one, the slope is still 8. And this time, though, you got to use these points in the formula. Not going to do it. That's child's play. 18. They're going to get into missing components. So whenever they give you an A, it's very easy to panic. They're just saying it's an unknown number, and we're going to call it A. Given that the line is tangent to the graph of that at x is equal to minus 2. Okay. So we don't know two values of A here. We've got y is equal to A over x squared, so it's some number. And then we also know the tangent line is this. That's the tangent formula for the line. However, let's rewrite this in terms of ax. Sorry, this should be a y here. Let's rewrite this first in line formula. We get 4y is equal to ax plus 21. And when I divide both sides by 4, or multiply by the reciprocal, I get a over 4 x plus 21 over 4. It doesn't matter what 21 over 4 is. Boom. That's what's important, because now I have a slope. Now I know that the derivative of this is going to be equal to the slope, and at x is equal to minus 2. So let's work on the derivative of this. What's the derivative of this? It's a times x to the minus 2. You bring the minus 2 down in front. You get minus 2a, just treat a like a number, x to the minus 3, which is equal to minus 2a all over x to the power of 3. That's what this is down there. And you might say, oh, I don't know what that is, except that they gave you. So now we know that's the formula of the tangent line for this. Was it negative down there? No, it's not. And it's going to be equal to this slope. And you might say, well, I have two missing things. I have x missing and I have a missing. Nope. So what's minus 2 cubed? Minus 8. We want to get, let's get rid of all our denominators first. So I'm going to multiply this left side by minus 8 over 1, which means the right side is going to get multiplied by minus 8 over 1. So this cancels here. I'm left with minus 2a. And on the right side, I'm left with minus 2a. Woo! All I did was prove that something is equal to something, so that didn't help me at all. Although I think it might mean that a is 0, but I don't think so. So that was a lot of rigmarole for nothing. And that makes sense because they already told me the tangent line is that. Determine the value of a, given that is tangent to the graph at that. So they already solved it for me. Oh, I think I can come up with two values of y in terms of a. So what is y equal to? Y is also equal to a over minus 8, which is what happens when I plug that in. Since I have a value for y and I have a value for x, I can plug it into the tangent line they gave me. Sometimes, you got to fiddle with these things. Okay, so let's give some space here. And I'm going to replace all my x values with what I found on the right and all my y values. And the reason we do this is because if you have this in terms of let me just make sure I got the right thing. Yeah. A, x. So I got to replace wherever I see. I'm just going to do it by hand. So I'm going to replace x with this up here, which is a over minus 8. Or sorry, x is just minus 2 times minus 2. And I'm going to place my y with what I discovered here, a over minus 8. And plus 21 is equal to 0. Now you can see I only have a's in here. So I just got to expand that. So this becomes positive. So I get minus 2a plus a over 2 plus 21 is equal to 0. I can just multiply everything by 2. So get minus 4a plus a plus 21 is equal to 0. Minus 3a plus 21 is equal to 0. Minus 3a is equal to minus 21. Therefore, a is equal to 7. And if you go back and you put a 7 in here as the equation, and a 7 in here, you will probably discover that it works. Okay, so the formula for this one is minus 14 over x to the 3. That's the formula of the tangent. And we're saying we're going to be equal to the slope of 7 over 4. Woo, when x is minus 2. So you get minus 14. I might have made a mistake here. Over, no, I got it. Over minus 8. These can both be divided by 2. And they both become positive. So I get 7 over 4 is equal to 7 over 4. So I proved it. A is 7. And so that was the secret here, was replacing y in terms of a and using x as the value we already know. and then you can solve for A. Whenever you're missing one variable, you can solve it if everything else is numbers. When you're missing two variables, you need two equations. When you're missing three variables, you need three equations to substitute. It can be shown, oh, I remember this, that from a height of h meters, a person can see a distance of d kilometers to the horizon when going up the CN tower, let's say, where d, the distance you can see, is based on your height of your tower. So let's put the CN tower here, bad drawing. And what they're saying as we go up this h, and you might say, oh, that's the y-axis. It's not. We can see d distance. I'm just showing you what you can see. I can see all the way to New York City. And if you go high enough and there's no clouds, and ignoring the curvature of the Earth, you can indeed see huge distances. That's why you can see so far up in space. But really, on the axis here, they're saying the height of the CN tower is going to be here. The distance you can see, distance I can see, is here. And it's based on this. So clearly this is going to be a graph like that. Okay? And you can see that the distance doesn't get, the height I can see doesn't get that much better as I go up higher. It still takes a long time. Oh, actually, no, I think it's saying that, yeah, I can see a huge distance once I hit a certain height. Let's see, as I go along this height, as my height includes, no, I can only see a limited distance, and that makes sense. Okay, so when the elevator CN tower passes 200 meters a night, how far can the passengers of the elevator see across Lake Ontario? So that's easy. You just put 200 in there, and the distance they can see is going to be 3.53 times the square root of 200, which is 2 times 100, which is 3.53, which is 35.3 square root of 2 kilometers. And that's accurate without making it into decimals. You can find the decimal and multiply this, but then you're going to get less accuracy. If you can't see how I did that quickly, study. Find the rate of change in the distance with respect to the height at precisely 200 meters. So for that, we're going to have to take the derivative. So we've got d is equal to 3.53, and it's important to keep your x as, or sorry, h, and now it's to the half. So this half goes in front, so that becomes 2.3, and this becomes negative half. So it essentially goes down here to the square root of h. So now I know that h is 200 again. So I end up being 3.53 rather, divided by 2 times 10 times the square root of 2. And that's what happens when I put 200 in here. I can bring the 10 out and left with square root of 2, is the distance in kilometers per meter of height. So it's a rate that I can see as I'm going up. So the 200 mark, my distance is 3.53 kilometers per meter that I go up at that spot in the elevator. So then she's saying I can see 3.53 kilometers for every meter I increase at that stage. That's how fast my distance is increasing based on my meter height. Oh, all divided by 3 and 10. It's all going to be divided by 30, and so it's actually going to be quite small. It's going to be like 3 meters. And you could convert this kilometers up here. Especially, is height given in meters? So you should convert this kilometers here to 3,530. And when I divide it by 20, I get 353 divided by 2. So I get 177.5 over square root of 2, because I didn't take that out, meters, because I switched my kilometers to meters, per meter that I go up in height. That's my rate of change. That sounds confusing, but it's a rate of change based on, that's why they had it in kilometers. And you can see this becomes 1.42, and the answer, if you work it out, becomes about, 70? I can see 70 meters per meter of increase of my elevator as I go up, something like that. All these numbers are accurate, though. That's not a hard question. And word puzzles, they're hard, but you just got to understand the graph they're showing you. All right? An object drops from a cliff that is 150 meters high. The distance in meters that the object is dropped in t seconds is modeled by this. So let's understand what we're looking at. Even though they're giving an upwards facing parabola, and you're used to a downwards facing parabola for time, for something that's falling, what they're showing you, as this time clicks on, you can see that the distance that it falls really accelerates as the time clicks on. And that is because acceleration, as you drop from gravity, really makes something speed up distance per every unit of second. Find the average rate of change in the distance respective to time from 2 to 5. I don't want to do that. Essentially, you find 2, you find 5, and you take d of 5, what you found for 5, you subtract d of 2, and you divide it by 3 seconds, which is your delta x. Okay? That's all you do for that. Find the instantaneous rate of change of distance at precisely 4 seconds. For that, we'll need the derivative. So we're going to take this, and we're going to figure out that the derivative is 9.8 t. 2 comes down, multiplies the 4.9, and the 2 gets lowered to 1. And at 4 seconds, it's 4 times this, which is 39.2 meters per second is how quickly it is falling at that specific time. Guess what? 1 second later, this is going to go way up. Find the rate at which the object hits the ground to the nearest tenth. Okay. That is when this whole equation up here is equal to 150 meters, because this is the distance, and the distance it was dropped is 150. So when this matches 150, that is when it hits. So you're left with t squared, and we'll only deal with positives because we know that there's another t over here that's negative. We only care about the positive. So that's t squared is 150 divided by 4.9. Take your calculator, take 150 divided by 4.9, and then guess what I'm going to do to it? I'm going to square root it. So we're left with this. That, and just round up there, let's say. Boop. Which means time, and technically it's also a plus and a minus, because you'll find this over here on this side, the minus, but we only care about the plus. So at 5.5328 seconds, this object will hit the ground. That's because I know it only has to travel 150 meters, and it only has this time. That is a very non-derivative question. Number 21. So we're giving this, a subway train travels from one station to the next in 2 minutes. Its distance in kilometers from the first station after t minutes is given by this. So the distance is based again. Oh, be careful. Let's rearrange that. At what times will the train have a velocity of 0.5 kilometers per minute? Okay. So I like to rearrange my things. Get rid of that. I like to put my biggest powers first, because now we can see that this is actually a cubic graph, which would normally start in quadrant 3 and go up, but this negative means it's starting in quadrant 2 and ending in quadrant 4. So that helps to know. We're also only concerned about time 0 seconds. So at time 0, it's clear that we go through origin, right? We go through origin. I'd like to see where else I hit some spots here. I'm going to take a t out, and I'm left with t squared. Actually, I'm going to take t squared out, and I'm left with minus a third t plus 1. And that means this is also 0 when it equals 1. So that would be minus a third t plus 1 equals 0. which means minus a third, is equal to minus 1, which means when t is 4. So it goes through this 0 twice, so it kind of flattens, comes up, goes down at t is equal to 4. So I'm going to redraw my cubic, and I'm going to have it come down, bounce off the origin, come up, and go down through here. And we're going to discover that you can also discover what this maximum point, because that's when the tangent slope is equal to 0. But anyway, it goes through 0, 0, and 4, 0. Important to know, just out of curiosity. But is this given in... Oh, this is given in minutes, so 4 minutes. So it reaches the station somewhere over here. Subway train travels in distance. So this might have been useless, but it just helps to understand what you're looking for. So they want to know when the derivative is going to be equal to that. So we have to take the derivative of that. And I like my version here better. So the derivative of this one is going to be minus t squared plus 2t. Because when the 3 came down and multiplied this, it got divided by the 3, and then it got reduced by 2. And now we just have to figure out when this is going to be equal to that. Clearly, we have a trinomial. So if I put everything into this side, I get t squared minus 2t plus 0.05. And if I just multiply things by 2, I get 2t squared minus 4t plus 1. And now it might be easier to see, and I don't think it is solvable. Well, we can use I'm going to go back to the original one just in case I made a mistake there. We can use substitution. For instance, we can say, let's test out t is equal to 1. We get 1 minus 2 plus 0.05. Does that equal 0? No. And we can say minus 1. We get minus 1 plus 2 plus 0.05. No. And we can say, oh, wait, I forgot one here, didn't I? Was it minus? No, it was plus because I moved everything to the same side. Yeah, plus 2t. Yeah, got it, minus 2t. And then I can use 2, so I get 4 minus 4 plus 0.05. And then I can use minus 2. So I get 4 plus 0.05. And so we can see that we have to use the quadratic equation, but I'm just going to use Symbolab. And who knows, maybe there's no solution, but I'm pretty sure there is. So we're going to do solve t to the power of 2 minus 2t. And this is really, you just have to remember that this is quadratic formula is something we needed to learn, and I'm just not going to do it, is equal to 0. And I'm going to ask them to solve it for me. And he's going to come up with these two t values. So we can see it's quite confusing. So these are the possible answers. And I would not use the negative one. And you can use quadratic equation and get the same answer. So this one is positive and this one is positive. So there's two possible times, which makes sense because remember that thing I drew? On the way to this point here, it's going that speed, and on the way down. But if they're saying that we're only dealing with the first 2 minutes, right, that would mean only this answer. Because this is past 2 minutes, is it? Nope, they both might be that. So they have two possible speeds where it hits that point. If you do your quadratic equation, you'll discover this. And look back at your quadratic equation to remember. Google it. I'm not here for quadratic equations. But essentially, it's when you don't have an easy factor, you've got to use the quadratic equation. Clearly, this is not an easy factor. But yeah, it's when this derivative is equal to that tangent line. Two possible times right there. And this is exact. That's why you keep the square roots. If you divide it out, you get roughly 2.4 something. And this one will be roughly, actually this one will be about 2.7, and this one will be roughly 0.7, something like that. You'd never do that though, because you want to keep it as accurate as possible. Here's that guy dropping the bolt. There we go. Part C I might not do. Okay. So you're just going to have to accept that sometimes the solutions aren't evident. While working on a high-rise building, a construction worker drops a bolt 320 meters above the ground. So let's visualize that. Here's the guy, and he's way up here at the top of the building, 320 feet up. And he drops a bolt and has fallen a distance of s meters, where we're given a distance based on a square. So we're given a parabola, upwards facing. Now you might say, oh no, bolts fall down like that, but they're just using this based on time to show us the distance the bolt has fallen. So essentially down here at 0 is 320, and then the bolt is going far away. Or if you want to count this guy's position where he's standing as origin, the bolt is moving farther away from him. And I know conceptually that's hard. So it's going based on this parabola, and it only goes for 8 seconds. Okay, so that means it goes from 0, and when we put 8 in there, we get 5 times 64, which is 320. Well, of course. So it's going from the top of the building, essentially, down to the ground. The function that gives the height of the bolt above the ground is this. Oh, okay, so now they've converted it into a downward-facing parabola for us, which makes sense. They took the height, and they're subtracting this acceleration. Use this function to determine the speed of the bolt at this time. Fair enough. So we can first find the derivative of that, and as you know, I like to rearrange it. Well, good news is the derivative of this will be nothing. 2 in front of this is going to be minus 10t is the derivative, and we're trying to find out when it's reaching the bolt. Use the function to determine the velocity of the bolt. Okay, at t is equal to 2. Okay, so that's not the velocity of the bolt. That is the t. So it is minus 20 meters per second. So it's because they're giving you the t, you can punch it right in there. You can also find the height over here with this function. So it's going to be 4 minus 20. It's going to be 300 meters above the ground. So it's just started to fall. And it helps to know when you graph it, right, that 8 seconds is when it falls, so that 2 seconds is just the beginning of its journey. It's not going to be moving too fast. That one was pretty easy. Tangents are drawn from the point 0,3. So we've got another 0,3 to the parabola here. Find the coordinates of the points. Touch the curve. Oh, we already did this one. So this time, visually, if we look at it, we're dealing with a graph that looks like this. Okay? Goes through origin, and that's this one. And it's going to go, tangents are drawn from the point 0,3, which is over here. So I'm going to draw a separate point. And the tangents, if we draw it, well, this is a big clue right there. And the other tangents here. This one's going straight through to origin, so this slope is going to be 0. Find the coordinates of the points that these tangents touch the curve. Well, right away I can tell you it's going to be 0, 0, because the only way the point 0,3, oh, maybe I got it wrong, 0x, 3y, okay. I got it slightly wrong, sorry. So 0, 3 is up here, not 3, 0. And guess what? The tangents are going to be very similar, because this tangent, because we're on the vertex, we're on the axis of symmetry, is going to be the negative opposite of that tangent. They're not going to be reciprocals. They're going to be negative opposites. So it's going to be a positive one here and a negative one here. Let's see. Okay, so first of all, we know the point, and we know the point between x and y, and we know what the tangent formula is. The tangent formula, f prime of x, is equal to minus 6x. So we know that this is going to be the slope, and we also know the slope is going to be the, let's call this over here xy. We know it's going to be y minus this y minus x over divided by x minus this x, 0. Great. All right. Well, we happen to know we're trying to find x, right? And we need to replace y with something. Well, we happen to know that y is also going to be minus 3x squared. Now we have a solvable. I'm just going to shrink this and put it in the corner. Now we have a solvable thing. Over here, x minus 0 is just x. So how do we get rid of this x first of all? Let's multiply by x over 1 on both sides. And we're left with minus 6x squared on the right side. On the left side, these cancel out, is equal to minus 3x squared minus 3. Now notice we're only left with x's and we can solve it. When I bring this 3x squared over to this side, it becomes positive, and I get minus 3x squared because I'm adding negative 6 apples plus 3 apples. And all of it is going to be equal to minus 3. When I divide x by negative 3 on both sides, I'm left with x squared is equal to 1. And when I take the square root of that, I get x is equal to plus 1 and x is equal to minus 1. Now I can substitute that into the equation. And when I plug 1 in, my value of y is minus 3. And when I plug negative 1 in, my value is also negative 3, which makes sense because I started on the axis of symmetry. I'm going to cut points that are going to be along the same plane. So the points we're talking about are 1, comma, negative 3, and negative 1, comma, negative 3 over here. They're going to be along the same plane because the point I was drawing to is along the axis of symmetry. Boom. A little bit of logic. You just got to understand your graphs when you're doing these and understand what's being asked. And I find what happens is people get boggled down on the words. Okay, crop. The tangent of a cubic function, so cubic function is just something to the power of 3, is defined by this. The tangent to the cubic function, this is the cubic function, at this point, intersects the curve at another point B. So we got another curve B. Find the coordinates of point B. Illustrate this with a sketch. Let's start with the cubic function. What happens when does this have a factor? What happens when this is 1? 6 plus, no, doesn't work. What happens when this is minus 1? You get minus 1, minus 6 plus minus 8. What happens when this is 2? You get 8 minus 24 plus 16. Boom. So this might help me. So I've discovered that when this is 3, when x is equal to 2, this whole thing is equal to 0, which means that x minus 2 is a factor of it. Now this might not matter, but I like studying my curves a bit. Okay, so that means I can take with synthetic division. So when this drops down, I multiply it by 2. This drops down to 1. When I multiply it by 2, I get 2. And when I add them, I get minus 4. When I multiply this, I get minus 8. When I add them, I get 0. Which means my... Does that make sense? I get minus 4 and 0. Which means the... Geez, what does that mean? Shouldn't I have gotten 3 of them? Drop that down, multiply by 2, add it. Minus 4, multiply by 2, minus 8. Add it. 0. So that means, what does that mean? Does that mean my other factors are x minus 4? Shouldn't it mean that I have x squared minus 4x? Oh, I see what it means. That's what it means. Squared. Plus 0. I think that's what it means. Just to confirm it, I think if I multiply this, I'm going to get x cubed minus 4x squared minus 2x squared minus 6x squared plus 8x. Yeah, that's what it means. It means that this is the factor of that, and it's clear that one of the factors when I take that out is x, and this is another factor. Great. So I just wanted to do that for myself, and that's so that I can see this cubic visually. So I now know I have a cubic that comes up and passes through origin, comes up, goes through 2, 0, goes down, comes up, 4, 0, and goes off. And it's saying the tangent to this cubic function at this point intersects the curve at another point B. Find the coordinates of point B. Okay, well, let's find the tangent here. So all this might have been for nothing, but it's more for me. So I'm going to just shrink my thing and put it up here. And I'm going to find the tangent to this. And definitely I made it more complicated than it needs to be, but I just wanted to understand my curve. So when I take the derivative, this is what I get. This is the derivative of that. And that last one is an 8. Should be able to see that by now. And they're saying that this is at this specific point 3, 3. So if I put 3 into this, I'm going to get the slope that goes through this line. Fair enough. Oh, intersects its own curve. Ah, intersects its own curve. Okay, so let's find the slope of this line. So when this is I put 3 into here to figure out the slope of this curve. So I get 3 times 3 squared, which is 9, which is 27, minus 3 times this, 36, plus 8. So I get 35 minus 36, so this all comes out to minus 1, which means the slope at this point is equal to that. So now I can do a line formula. Great. A line formula. So I get y is equal to mx, and I know the m is minus 1, x plus b. And now I can figure out my b, because I have the points 3, minus 3. So I get minus 3 is equal to minus 3 plus b. So b is equal to 0. So this is the line. And I'm talking about 3, minus 3, which is probably right down there. And I'm talking about a line that goes down like this. Beautiful. Look at that. So the question is, when does this line intersect the cubic curve again? Well, two lines, any two equations, any two objects are going to equal each other when their formulas equal. When their formulas equal. Which means this is going to have the same y coordinate as the line that I just discovered, which is equal minus 1x. Is going to have the same, this line is going to meet this curve when we can solve this. Okay, I'm going to bring 1x over here. Can we solve it? Yeah, and I'm left with 8 cubed minus 6x squared plus 9x is equal to 0. Okay. I can take an x out of each of them. I'm left with x squared minus 6x plus 9 is equal to 0. So we can see definitely 0, 0 is one of the points. And when I solve this, ooh, that's a perfect square. X minus 3 squared. And x is that. Well, we already knew this point. When x was 3, when x is 3, we knew it went through this graph. But as we can see, when x is 0, so it's 0, 0 is the other point. It goes through the graph. Therefore, point B is 0, 0. Seems very confusing, doesn't it? So the first step is finding the formula for the line of this tangent, using this point and what the slope of the tangent will be. Once you find this line, which I have here in red, you can then make it equal to your original formula, which is here, because anytime something crosses another formula, another curve, their formulas will be equal only at the points they cross. They will only share x and y values. This is essentially what it means. They will only share x and y values at the points they intersect. Other than that, when this curve is going off that way and this line's going off that way, you can see they don't share any x and y values. They only share an x and y values where they cross, which is why you can make one equation equal to the other equation, and that's where they will cross. Always. Okay, the last one here, 25. And again, I might not do part C. That's probably stuff to talk with your professor because it's always advanced. Find the coordinates of the points, if any, where each of the function has a horizontal tangent line. So what's a horizontal tangent line? Where the slope is 0. So we take, and they keep loving to arrange this wrong, but anyway, I like having it in the right order, which is this. Okay, and I can easily see that the formula for this tangent is this. And then I just have to make it equal to 0, because I know a horizontal tangent line will have a slope of 0. And I get this. And I get this. How come I made these both positive? Because I made minus divided by minus, which is this. Now I got to take the point, plug it back into this, which by the way is a parabola. And it should only have a horizontal tangent line at its vertex. So that means this is going to be the vertex. Yeah, so that's another thing to realize. The only point that the parabola is going to have a horizontal tangent line is at the vertex. And so when we plug it into a fifth, we get 2 times a fifth, which is 2 fifths, minus 5 times a fifth squared, which is 5 over 25, which is going to be, when I put this over 25, it is 10 over 25 minus 5 over 25, which is equal to 5 over 25, which is a fifth. So we can see that the vertex here is 1/5, 1/5 is the point where that's horizontal. Again, this is a parabola. It's only going to be horizontal at its vertex. So you could even just plug in and find the vertex. And you can complete the square to find the vertex too. You can also factor it. So minus 12 and plus 2, but factoring might take a lot longer. Minus 12 and plus 2. They're going to be very close to each other. Yeah, so I'm not going to do that. But I could complete the square as well. How do you complete the square? You have to treat the middle part as all alone. And you have to get the x all alone. And then you have to figure out what would create that. And it is x minus, what was it, x plus? plus a quarter squared. Becomes x squared plus a quarter plus a quarter. Yeah. And so we discover that, but when that, actually that's all I need. So I now know that the vertex is at minus a quarter x, and I could plug it in. But let's do it the long way and see if I was right. Will x be minus a quarter, which is the vertex? That was called partially completing the square. Well, let's find the slope of this, or the tangent derivative. Plus 2. When will that be equal to 0? When 8x is equal to minus 2. Oh, look at that. When x is equal to minus 2 over 8, or when x is equal to minus 4. Plug it into that. You get 4 times 1/16 minus 2 over 4 minus 3. This becomes 1/4 minus 2/4. So you get minus a quarter minus 3. So the y version is minus 3 1/4, which is also minus 13 over 4. So you get minus 1 over a quarter for the x, minus 13 over 4 for the y, is when that vertex, essentially when that parabola has a flat. Now, cubics can be flat in more than one place. It can be flat in 2 places. So that's where you have to do a derivative of cubic, or if you can figure out where, oh, and here's what they're teaching you here. And there we go, graphical interpretation. Here's what they're teaching you. They're teaching you in a vertex, this one in a cubic, which is positive. Where's the slope 0? Here and here. So we're going to learn how to find the maximum, local max, local min of vertex by finding the slope 0. So remember this. So first step, find the derivative. There's the derivative of that. Set it to equal to 0. The only way we can do this is to find out two numbers that multiply out to 15 and add up to minus 16. And those two numbers are obviously minus 15 and minus 1. Now, my slip and slide method, let's see if that'll work for me here, though. Sometimes it fails, and you always have to verify afterwards. You divide by 3 here, divide by 3 here. This one becomes 3x minus, what's 15 divided by 3? Minus 5. And here's the slip and slide part. You have to take this 3 and put it in front of the x. Now, just to make sure, I do a quick expansion. 3x squared minus x minus, minus 15x. What have plus 5. Yeah, there we go. Those are the factors, which means this will have a slope of 0. You'll set it all to 0. When this is equal to 0, this bracket, or this bracket's equal to 0. Well, this bracket's equal to 0 when x is 5, and this bracket is equal to 0 when x is a third. If you're not sure, put a third in there, multiply by 3, and subtract 1. And now that we have the x parts, we have to go back here and put it in here to find the coordinates. So essentially we're finding the local max and minimum of a cubic graph. Very useful later on. So 5 cubed is 125, minus 8 times 5 squared, which is minus 200, plus 25 plus 3. So you see that this is going to be minus 75 plus 25, so it's minus 50 plus 3, minus 47. So one coordinate is 5, comma, minus 47, and I'm not going to put this in, well, maybe I will. So a third cubed is 1 over 27, minus 8 times a third squared, which is minus 8 over 9, and then the last one is plus 5 over 3. You will discover that they all have 27 in common, so I'm going to multiply it all by x over 3. I'm going to multiply it all by 27. It's all equal to 0, by the way. And so, or sorry, no, this is all the x. I'm going to multiply it all by 27. So I get 1 minus 24 minus I don't know if this will work actually. Plus 45. Yeah, I don't think that's accurate. I don't think I can do that. So I get minus 1 over 27 minus, what is this over 27? I have to multiply it by 3, minus 24 over 27, and then plus 5, I have to multiply this by 9, plus 45 over 27. Yeah, I could have, I just had to keep everything over 27. So I'm left with, what's 48 minus 24? It's plus 24 plus 1, so I'm left with 25 over 27, which is essentially 1, 2 27ths. So the point is x 1/3, y 1, 2 27ths, or y 25 over 27ths. Was it 25 over 27ths? Yeah, so you just leave it, it's not 1. 25 over 27ths. 1/3 and 25 over 27ths. And you've discovered right away on this cubic, you've discovered its local max turning point. Its turning point, there you go, here, and its turning point there. Going to be very important later. Not very, but somewhat. Part C. Don't know if I'm going to do all part C. I think this video's already gone on for an hour. Okay. This is again where if I can't solve it quickly, I'm going to get back to you on the next video, okay? Let point P be a point on the curve. And this is essentially a circle. No, it's not. Show the slope of the tangent is that. Oof. Okay, well, let's put this instead of in terms of y and see how we do. Square both sides. Difference of two squares here. Or sorry, when I add it up, I'm going to get 1 minus 2 square root of x plus x. Okay. Don't know if that's totally valuable, but that's what y is equal to. Show the slope of the tangent. Okay, so now that I have this, I can find a derivative. So I know that's going to be nothing, so I'm really only concerned with this part of it. I know this is going to just become 1. And so this is going to be minus 1 over x to the square root. If you don't know how I figure that out, it becomes half times the minus 2 becomes minus 1. X, the half minus 1 becomes negative a half, which just sends it to the bottom as a square root. So this is the formula for the tangent of that. Now they're saying, prove that for point A and point B, that this whole thing is going to be this, equal to this. All right. That means if I substitute y up here, or sorry, if I substitute x up here, it's equal to that. Which doesn't quite give me enough information because we can see that there's a point B in here. Okay, let's leave this like with an A in it instead though. And we're going to solve y here so y is point B. So B is equal to 1 minus 2 square root of A plus A, right? Because point B is the result of this formula with A in it, okay? Which means over here, I can replace B. Let me just make the square root bigger and the minus over here more. I can replace B with all of that. And where I see X, I can also again replace it with A. Okay. So now I have something that's all in terms of A. First step would be to get rid of this minus. No, it's already a nightmare. Yeah, I don't know if this is the way to do it. So I'm going to go back and study this more because I can just go on for hours here. For the power function, x to the n tangent point 1, what happens when x increases when about now? Teacher, ask your teacher. For each function, sketch the graph of f of x and find an expression for this. Indicate any points with f. Okay. So in this case, they're giving you a piecewise graph, a normal absolute value, and a bizarre absolute value. So they're just giving you really complicated graphs to work with, right? So here it is here. I'm going to work on 26 though and see if I come up with an answer that's a little bit faster and clear. So in this one we have to look at x to the left of 3. So when x is 3, we're talking about 3 comma 9, and it only exists to the left, and it's just a normal parabola, right? So here at 3 comma 9 we have a hole, and then it goes up to there. Then we just have to look at what happens with 3 down here. 3 is also 9, and it includes 3, and it's a line. So we have a line that essentially goes up like that, and there. Now, I think that's a sharp turn, so that there's no f of x. But what you could see is the derivative, so there's the points, the derivative of this one up here is 2x, and the question is, will it equal to the derivative of this, which is just going to be equal to 1. It's quite clear, because this is the derivative of the line, the slope. It's quite clear that 2x can only be equal to 1 if x is a half. Well, no, x is 3. So you can see that at the point where they meet, when x is 3, the derivative of the first function, its velocity, essentially its rate of change at that point is, well, I've got it all on the 3. The 3 should be on this side of the graph, sorry, is 6. And you can see from this function, the rate of change is 1. Since we don't have the same rate of change coming from right and left, it doesn't have a definition. This one, I can tell you right off the bat, also does not have a derivative, because if you look at this graph, this is how you graph it. Find the vertex of this. The vertex of this is going to be 3x squared is equal to 6, x squared is equal to 2, x is equal to, do I just use the positive? Square root of 2. If you graph this, you're going to see something where the derivative on one side is just the content, and the derivative on the other side is the content with a negative in front of it. So if I take the derivative of this, I get 6x. If I take the derivative of this, I get 6x times minus. So no matter what point I'm taking, one of them is going to be a negative, and the other is going to be a positive. So on one side of the vertex, you're going to get a negative 6x, and on the other side, you're going to get a positive 6x. Depends where the point of this graph exists. So if you look at it, it's a parabola that's lowered. Yeah, so look at the inside. It's a parabola that's lowered by 6, which means the graph is going to suddenly, wherever you see a negative values of y, is actually going to bounce back up like this. So all this part of the negative parabola, which is down by 6, is going to reflect up here. And you can see, so where does it not exist? It does not exist here and here. Where's that? That's when 3x squared minus 6 is equal to 0. So 3x squared is equal to 6. X squared is equal to 2. So that does not exist at the point minus square root of 2 and positive square root of 2, comma, whatever the y value is. When you put square root of 2 in there, it becomes 2 times 3, 6, 0. Yeah, 2 comma 0. There. Those are the 2 points that the derivative does not exist for that graph. For this one, the derivative exists everywhere except where they meet. So the derivative does not exist where x is equal to 3. And then for this one, They made my life hard with this one. This one I don't even think I can answer because it's a derivative inside a derivative, which is just a nightmare. It's easier to let me Desmos plot it for me. So what is a derivative? Get rid of that. F of x is equal to the absolute value of x minus 1, close brackets. Yeah, so there we go. So you can see that normally this is an absolute value that's lowered by 1. But so if we didn't have this second absolute value here, that would be the normal graph, and it would not have a derivative at its sharp point. As it is, whenever it dips down into the negative, it gets reflected up. So at this point, negative 1 comma 0 and 1 comma 0, and this point 0 comma 1, there's no derivative because those angles are just too sharp. And for us to find that, I guess I could have figured out what the original thing in the center looked like. I can see that that's just an absolute value lowered by 1, and then I could find out when all these values bumped up like that, and then I could also find the vertex, and the vertex of course is at 0 comma 1 because it got reflected up. Yeah. So there you go for that. More conceptual than actual math.